Today I want to cover an advanced topic. Something came up this week that I think you appreciate seeing, since it involves a hidden function in support tool. The Model 410 web server supports secure connections. That's different than the Series 3, which most of you are familiar with. And you can recognize a Series 3 for the white label and a Series 4 for the black label. Series 4 has a blue LED. The power LED for the Series 3 is green. Otherwise, outwardly, that's the only appearance difference. The Series 4 has a much more sophisticated web server. In fact, the TCP over IP stack is much more sophisticated and capable. A lot of things you couldn't do on the Series 3, you can do on the Series 4. One of those is making a secure connection. Someone mentioned to me this week, as I was working on version 1.5.1 of JANOS, the current version being 1.5, 1.5.1 is due to be released later this fall, that the secure transport process seems to be running at 100% CPU and running up a lot of runtime. So it occurred to me that if you're developing code for the Junior, or you're interested in just what the Junior can do, how sophisticated JANOS can be, you'd like to see how someone would recognize that a particular process even existed, or that that process was consuming 100% of the CPU time. Now in this case, and I'll demonstrate, but that 100% CPU just means that the process is busy all the time, but it wasn't consuming the CPU to the point where other processes had to contend. In other words, it just kept checking to see if it had work to do and otherwise yielding its time slice. But it didn't sleep. And so I've adjusted that for version 1.5.1, but let me show you the difference. So we'll go over to the desktop. Now at the desktop over here, if we bring up the support tool, this remote unit is the one right here on under the camera. I will go into the feature. Now if you right click, you're presented with a number of options, capabilities, but if you hold the shift key and right click, you get this extra one, chart memory. If you click on that, that creates a tab specific to this unit. And that tab will plot for you the heap memory status. Now on this chart here, there's some parameters dealing with the current status of the memory. And on this chart here, there's the number of free blocks the memory management model deals with, and the CPU percentage from 0 to 100%. So I have this particular unit charting now, and I've updated the speed to 0.5, so every half second it's updating. Typically this is 5 seconds by default. And the viewable duration I've changed to 15 minutes. It's usually 60 minutes by default. So if you do bring this up, you might want to change those two configuration parameters. And we see here that we're running at about 31.6 megabytes, in fact 31.62 megabytes. And there are two other lines that will show up here. This yellow line is a total of large blocks. Gives us a feeling for how fragmented the heap might become if the number of large blocks is increased and the blocks sizes are smaller. And this red line, which falls below this chart because this is only showing from 32 to 30 and the red line's not forced to be on here, is the largest free block, which typically needs to be at least 128 to 150K on these units, so that blocks can be allocated as needed. And so the free block count here is 88 that we're showing down here, and the CPU usage load right now is 0.1% because the unit is basically idle. So you can see the largest free block is 26.84 megabytes. And the ones that are greater than total of the ones that are greater than 32K is 31.35 megabytes all total. Now, this unit has 32 megabytes, the one I have here under the camera. A lot of units you'll get have 64 megabytes. That was just basically something that came with an update of a component on the board. There's a small set of units that were first built, the first 410s that were built after the 310s, that have like 4 megabyte heap memories, or even 2 megabyte heap memories, because that's what the Series 3 had. So there's about 100 units out there with that limitation. And so you can imagine that this chart would be even more of interest when you have a limited amount of memory to work with. With 32 megabytes is far more than you need, and as you can see here, memory just runs up close to the top of that. Now, how do you know what processes are running? Well, that's usually done, in the command line. So if we open a telnet connection to the unit and log in, and use the PS command in verbose mode, it lists the processes. Okay, so we have an idle process, and then network services deals with network activity, system deals with periodic tasks, and you have a process associated with our telnet connection. And we see the runtime here. And in fact, you can see the process connections. We have a telnet connection on port 23. That's this window. So someone can look here and see what process is running and how much runtime is accumulating. How do you see if runtime is accumulating? You run the process command a couple times in a row, and you can see that time is being tallied against a certain process. So the comment that was made was that the secure transport process was running up runtime and running at 100% CPU. Well, nothing's running at 100% CPU right now, and there's no secure transport process because we haven't made a secure connection. Bring up the web server, and let's go to our unit. And that's it right there. Now, it's creating a secure connection. Memory runs down to about 30 meg. And you can see CPU goes up to 100%. Now, the cryptography involved with making a secure connection is pretty computationally intensive. And so it does consume 100% of the CPU, rightfully, during the negotiation of these connections. Some of these keys can take several seconds to calculate. So as we're making connection to the unit, here we've logged in. By the way, if this is the first time you go to a unit, it will pop up a warning that the certificate, the self-signed certificate in the unit, is not trusted, and you have to go into the advanced on Chrome, hit advanced, and then say proceed to the site to allow the unit to accept that certificate. So let me log in here. Okay, and that's why this is red and crossed out. Doesn't mean it's not secure. Your communications are 100% secured. It just means that the certificate itself is not trusted. For a certificate to be trusted, it's a topic for another day, but it has to be signed by a national certificate authority, signing authority, GoDaddy or something, in order for the certificate to be traceable back and that's therefore trusted. And in this case, a self-signed certificate is used on all the individual devices, so you just have to approve it. Okay, so we brought up a secure connection. And you can see if we watch the junior over here that I can toggle the relays. Okay, so there you go, secure connection. Well, what's happened here? Well, during that process, we've used some memory and then released some memory, and now we're running at about 29.6 megabytes. And yes, something is sitting at 100% CPU utilization. We're not doing anything really. So why is the CPU at 100%? Well, that was what the comment referred to. And if we go over to this now, and if we do look at the process table, the web server is running, and then secure transport, which is another process that's supporting the cryptography side of the connection, is running. And you can see that it has quite a bit of runtime. In fact, if I repeat the PS command, the runtime seems to be going up almost in real time. And that was the comment. Now, this is not a problem in that it's not impacting the ability for any of these other services to get CPU access and time. It just means that the secure transport process is just continually checking to see if it has anything to do, and it could sleep. So I'm going to take care of that for version 1.5.1. And to demonstrate that for you, let's go to a unit that has the beta code in the office. So in the office, I use VNC to get to the office, and it's a dual monitor system, so I'll expand it and just showing you the left-hand monitor. Now in the office, we have a large number of units, as you'll see. Support tool comes up, zip. And my demo unit's not running here because it's hooked up to E² Studio, development code and debugger. So I'm going to bring up my demo unit. So this is going to be the latest code because this is the source code for JANOS right here. And in fact, it's all right here. Okay, and this is a beta 0 version that's available for people to use in the office. Let's execute this on the Junior that's connected. It does take a moment for it to download. This downloads the operating system to the unit. It also downloads, the boot manager gets downloaded, and JANOSclasses.jar, the etc folder content, which is the runtime class libraries that any Java application would use. So we have to wait just a bit for the debugger to load. It has to burn the flash every time this is started up. Now, those people in the office that are running the beta code, the unit boots right up. They don't have to worry about this debugger. My unit that I can get to from here, if we want to use that unit with the latest, absolute latest code, I have to go through this process. So ready to go. I can start it here, and it's now running. So let's just put this out of the way. And now, where's my unit? Well, it's called Bruce Dev, and it takes a moment to boot and connect with the network, and it should pop up here. It just did right there. In fact, if we look at the last announced, right here I am, Bruce Dev. Okay, right click here, got a selection of things, not the chart memory. Hold the shift key down, right click, here it is, chart memory. So we're charting memory here. Here's the memory chart for that unit. Again, I'm running at ½ second. I set that up for you ahead of time, and duration of 15 minutes. So we're on the same scale. And you can see CPU was busy initially and down here. And we're running at a free block count of 10. So there's nothing going on in this unit. So let's make a connection to the unit to see the processes. This is a tool that I have that actually has a little feature that recognizes logins, because you can imagine that INTEG employees get tired of entering the word junior for password and username. So if I connect on a serial port to that unit, which is connected that way, the login is handled by this little checkbox. Let's do ps-v, and here we are, the 3 services, and we've only been up for a minute and change. And you can see here that the serial connection had a slight impact in what's going on, but not much. All right, let's make a secure connection now with version 1.5.1. Yes, and we are talking 1.5.1 right here. Beta, build 0.1. Here we go. Let's make a connection to my copy of the DHCP. So we're making a secure connection, and during that, it's establishing a secure connection. Again, we have 100% CPU because cryptography is computationally intensive. And these keys, the 1024-bit keys that the Junior uses, can take several seconds, 4.5 seconds maybe, to calculate. But now we're no longer running at 100%. We're down here, you can see, at 5% load. So, world of difference. Did we make connection? There we are. This unit also set up not to require a login. I can also toggle relay here. I can't show you that. This unit's not on a camera. Okay, so that's a secure connection using 1.5.1. does not show the kind of CPU load. And if we go over here and we run the PSA over here to my, and we run the ps-v command, you can see that we have the web server and secure transport, although this number is a little bit lower than it was on the on 1.5, and it is not running real time. Now, this secure transport process is not doing any less work than it was on version 1.5. It's just not wasting time, logging the time it wastes, verifying that whether it has work to do or not. The change was made to allow that process to sleep, and it's awakened when it has work to do. So there you go, a correction in 1.5.1. No big deal. I wouldn't worry about that in your 1.5. You can still make secure connections all you'd like. But I thought maybe you would be interested in seeing this charting and how your unit might be working. If you're developing an application, Java application, it will show up here as a separate process, and you will be able to use this kind of tool to see, you know, what your CPU load level is and how fast the runtime over here is tallied up for that unit. You can also look to see how much memory is involved with that process. You can see if your handles are being properly maintained. These are things like standard out, standard in. You can see that the web server has multiple connections, so there are 21 handles used there. And you can also see what percentage of your stack is being used. If it happens to be that you're using a lot of memory, your handle number keeps going up, your stack is a high percentage, then potentially you should look at your code in your application to see if you can improve those parameters. Now, one last thing. When your connection is closed, all right, the process mix stays the same for a period of time, about 4 minutes. If there is no server activity in 4 minutes and no transport activity in 4 minutes, then these processes will terminate, and they'll start back up again when you make another secure or any web server connection. And you can see that once we close connections, there's a time wait period, and then the resources allocated, buffers basically, by the stack for the various incoming and outgoing connections are all released. And it sort of attests to the function of the memory management model, that when I release a large amount of memory, that the actual number of free blocks goes down. It peaked briefly, but then went down. And I mean, this is probably 100 blocks that were released, and this did not jump by 100. So you can see that. So this is this memory free block count is typical of any JANOS build, but this CPU running at a small percentage and dropping down when the connections are closed is now evident. Will be part of 1.5.1, which will be available sometime between now and Christmas. Okay, so after 4 minutes, this will stop. Let me run time ahead for you, and I'll show you that, and that'll be it for this today. Okay, a few minutes have passed, and you've caught back up to me. So let's take a look back and see what's happened while we were away. And you can see that each one of these squares is about a minute. And so 4 minutes later, as I mentioned, the services should have been terminated. So let's take a look here. PS minus B. Yes, they're gone. And the memory associated with all that has been released, which allowed the free block to grow. And we're back to the same status we were prior to our secure connection, which is a good thing. And again, as lots of memory was released, we drove the number of free blocks down. So there you have it. The functionality of the memory charting tab, which is available by holding down the Shift key for any junior. Here's a 2 meg unit.